Hello everybody, welcome back to another concrete beam design in spacegass. So this tutorial we're gonna use this beam for analysis. As you can see, this is a floor plan building. So typically we have some furniture in here, living space, staircase as well. But we're gonna focus on this area only. So as you can see in these drawings. So in order for us to start with analysis, we need to take the triplet area, which is shown here. So we take basically the span on the left, which is the left column to this column, a half span, and plus the half span on the right, which is from this column to this column. So these two distances add together, divided by 2, gives a value of 5.4. So 5.4 by 7.3. So this is the area we're gonna use to calculate our dead load and live load. So we also have some cross section here. Column 0.5 by 0.25, beam 0.25 by 0.83. So these two sections we're gonna assign later on in spacegass. Our loadings, dead load, live load. So loadings, we have tiles, floor 25. Take the density, multiply by the thickness 200 mm, to multiply by 5.45 to get this value. So ceiling, wall. So you take the unit width in kPa, multiply by height. Total height of the wall is 3.4. Get a value of 6.18. Height of everything together gives a value of 34.6. So similarly we have live load 3 kPa, then multiply by 5.45 to get a linear load along 7.2 mm beam. Alright, so now let's go to spacegass and check modeling. Go to structure wizard, click on this template. We know our length will be 7.3. Now our ground floor height of the column here 5.4. So our next level will be 3.4. Keep in mind. Let's assign a material, concrete 25. Beam cross section, I'm gonna put 830 bar 350. Click OK. Column section, $500 bar 350. So 500 by 350. This is the orientation of the column, as you can see in these drawings. So this is 500, 350. So 500, 350. Click OK. Support beam. Let's not forget, we also have our cantilever. So let's go to structure, member, let me draw cantilever here. So 1.48. Click on OK. Now cantilever is drawn. Let's assign loadings. So that will be our first load case. Now go to your drawings. So dead load will be 34.6. Negative 34.6. Okay, so in the y axis, which is the y axis in the global space of spacegass. Click on OK. So this will be G. Let's also assign our live load. Live load 2. So our live load will be 16.3. Negative 16.3. So 16.3 in here. I'm going to copy Q, live load Q. Okay, so now that everything is selected, let's click on this beam. Let's replicate it up by 3.4. So copy, type 3.4 meter. 3.4 meter. So number of copy we need only one. So make sure your copy load is checked. So now my beam is replicated. Simply go to here to draw my column from here to here. From here, make sure this is my column. So put section 2. There you go. So section 2. This is my column. Click OK. You can turn this on to see. Okay, so now let's replicate this flow up. So we need how many more? We need 1, 2, 3, 4, 5, 6. 6 extra flow. So click, right click, click copy along the line, then click zoom in. So just type zoom in here, and click. So how many? We need 6. Click OK. So now all the flow are replicated. One thing, as I've said, we only have taken live load and dead load, but normally we also assign earthquake loading as well to account for the overturning moment and shear base. Okay, so now that everything is done, let's go to analysis, analyze. So we're gonna select all the load cases. So one thing I forgot. Let's put our load combination. So C2. So 1.35. This will be our load case 4. It's 1.2 plus 1.5. Next will be our serviceability load case. So 1, factor of 1, 0.6. Click OK. So let's analyze. Click analysis. Select all the load cases. Then click analyze. So now that analysis is completed, let's go and see some results in here. So load combination, for example, this is a binding moment. You can also see the value in here. So this is a binding moment for combination 1, strength combination obviously. Strength combination 2 is 1.2 plus 1.5 Q. This is our serviceability load case. So let's check on deflection. So basically, a deflection in the one direction 7.58. So we know that our span is 7.3 divided by 250. This is the value of 29. So 29 mm. So still within the range. So I'm not worried too much about that. So now that we have check on deflection, let's go and check out beam. So beam design. Right, so this is our beam design. So beam is passing. Make sure that all the load cases are selected. Beam is passing. These are reinforcement detailing. As you can see, the spacing gets larger at the middle of the span, but gets closer to the support. If you go to the here, this is shear force diagram. So you can also go here, export the drawings, and fit them later on in AutoCAD. Okay, so our beam is passing, so you can also check cantilever. concrete beam, still also passing. We can check the ground floor column as well. Go here, check the ground floor column. Column is not passing. Obviously, you can also increase the size of the column to finalize it better on. Alright, so you can also check the top floor as well. Let's say this concrete beam. So my beam is passing. You can also check the column here. Put the design, concrete column. So obviously my column is passing. So clearly it shows the ground load. There is high moment, also high axial force. But yep, that's how we check. We can also go here to optimize my beam. So I'm going to here. I think my beam is a little bit too high. I can put it 600 for now to save cost. Go to analysis, run analysis. Let's go and design a beam again. So my beam is still passing. Let's check our deflection. Obviously still within the limit. And so that way you can also design and optimize your section literally like in a very short period of time in spacegass. But this column you can also go and increase the size to make sure it's also passing. So yes, that's how you do concrete beam design in spacegass. Thanks so much for watching. Subscribe to my channel. See you in the next video.